Hello, students. I will start paper 3, okay, solving one by one. I will take the maximum 5 to 7 minutes. I will do each part of the question and put it online, okay, so that you can go through it and then next part I will put. So it will be in a playlist, right? So we will start with May 2024 TZ1, paper TZ1. You know that this is 1 hour paper. There will be 2 questions, right? And you are allowed to use GBC. Okay. Okay. So let us start with question 1. It says, this question consider two possible models for the occurrence of the random event in a computer game. There are two models. Okay. Now, first model says in a new computer game, each time a player performs an action, there is a random chance that the action will be boosted, meaning that it provides a benefit to the player, right? The designer of this computer game is considering two possible models for when to boost an action, right? So that he is going to use two models. In the first model, this is the first model, the probability that an action will be boosted is constant. It remains constant throughout the experiment, right? Suppose the probability that an action will be boosted is 0.1. So P is 0.1. Okay. Find the probability that the first boost occurs on the third action. So look here. Here I'm going to solve on the next page. Right. Now look here. The question says the first boost occurs on the third action. It means for answer of this part, no boost, no boost, and boost. Right. Now, boost is 0.1. Look here, boost is 0.1. So, no boost will be 1 minus 0.1. Okay. So, 1 minus 0.1 into 1 minus 0.1 into boost. Boost is 0.1, right? Okay. So, this is 0.9 into 0.9 into 0.1, which gives you an answer of 0.081, right? So this is the final answer of this part. So I hope you understood this. Now second part says, find the probability that at least one boost occurs in the first 6 actions. Now look here, this is binomial distribution because number of actions are fixed. Okay. So n number of trials 6, probability of success 0.1. What we have to find? And then this will be a binomial distribution x, b, and p, right? This is the parameter n and p. So x, b, n is 6, p is 0.1. Now first boost occurs, there is at least one boost, at least one. Okay, what is the meaning of at least one? One or more, right? So x greater than or equal to 1. Now I'll find it by calculator, right? So I'm using CG50, Casio CG50. You can use different calculator, right? So in Casio CG50, I'll go to menu, okay? And from menu, I will choose statistics mode. And in statistics mode, I will press F5 for distribution, again F5 for binomial, and F2 for BCD. Okay. Now lower is 1, lower is 1. There is lower and upper, right? Lower is 1 and upper we don't have. So 999, right? Number of trials, trial like that they have written is 6. Then P is 1, 0.1. Okay. So we will put all this and press execute. So my answer is 0.468559. So three significant figure will be 0.469. This is the final answer. So I hope you understood this part, right? Now, second part says, suppose the probability that an action will be boosted is P, okay? Where 0 is less than P is less than 1, of course. Explain why the probability that the first boost occurs on the X action is this. In the X action only the first boost occurs. Okay. So no boost, no boost. How many times? X minus 1 times. So no boost into no boost and so on will be X minus 1 times. And then into boost, right? Like that, it will be in the X action boost, right? So no boost is 1 minus P, 1 minus P, 1 minus P, like that, X minus 1 times into, sorry, X minus 1 times into boost, boost is P. So 1 minus P, how many times? X minus 1 times. Therefore, 1 minus P to the power X minus 1 into P, which can be P into 1 minus P to the power X minus 1. So this is the result they wanted from us. So we got that result, right? Now, look at the next part. It says, let X be the number of actions until the first boost occurs. Hence, write down an expression using sigma notation for E of X. You know E of X is mean, right? So the formula for E of X is sigma xi into PR, right? Like that, I from 1 to n, whatever is that. This is the formula, right? But now we already have that in terms of x and p, first boost occurs. Let x be the number of actions until the first boost occurs, right? So for that, what we are going to write? We will write sigma E of x, second part E of x, sigma, we don't know when it will occur. Okay, so x is from 1 to infinity. Okay, x means 1, 2, 3, 4. P is the boost, and 1 minus p to the power x minus 1 will be no boost. So x action will be a boost. When that x action occurs, we don't know about it. So therefore, this is the answer for the second part. So I hope you understood this, right? Yeah, so I will stop here. I will do next part in the next lesson. So till that, bye then. Okay.